The ventricles of the brain are fluid-filled spaces. They're lined by ependymal cells which modify plasma into cerebral spinal fluid. We're looking at the model from an anterior point of view, and you can see the two lateral ventricles and the third ventricle, which is in the midline. You can see that the third ventricle has a space in it, and from the third ventricle we're going to encounter the cerebral aqueduct that leads then to the fourth ventricle. Let me turn the model around so you can see it now from the back. And this is the third ventricle. These are the lateral ventricles. Here is the cerebral aqueduct, and this is the fourth ventricle. Cerebral spinal fluid that's produced in the lateral ventricles flows into the third ventricle. From the third ventricle, it flows through the cerebral aqueduct into the fourth ventricle. From the fourth ventricle, it makes its way through the medulla and then into the central canal of the cord. In the sagittal section of the brain, I'm going to first remove the diencephalon. Once we do that, we can see the space that is one of the lateral ventricles. On the other side of the model, there is a thin sheet of tissue that separates the two lateral ventricles, and this is called the septum pellucidum. Fluid flows from the lateral ventricles into the third ventricle. The third ventricle is located in the middle of the diencephalon, and it is this slightly depressed area that surrounds the intermediate mass of the thalamus. Fluid flows then from the third ventricle, which adds to the fluid that it received from the lateral ventricles. Fluid then flows through the cerebral aqueduct into the fourth ventricle. The fourth ventricle is located between the brainstem and the cerebellum. The fluid then continues to flow on the dorsal surface of the brainstem and then into the central canal of the spinal cord.